Okay, so in last session, we have seen different network topologies and different ports number, different networking devices. Okay, so there are different kinds of topologies. Some of them are bus, star topology, mesh topology, ring topology. Can anyone explain any of this? So network topology is basically used for the arrangement of networking devices in a network. So all devices can communicate efficiently and effectively to each other. So for that, we use the topologies. There are advantages and disadvantages of every topologies. So based on our preference, we use different topologies. Sometimes we also have to create the mixture of topologies for star. For example, the tree topology is mixture of bus and mesh topology. So we have to create topologies based on our network. And we have also seen different networking devices, for example, router, switches, bridge, and we have also seen different ports number. The most common ports number like FTP, which is used for file transferring, and the port number is 20 and 21. Then there is SSH port, which is used for uh, remote logging, and port number is 22. Then again, there is Telnet, which is also used for the remote login, but it is not secure. So it used 23 port number. Then there are SMTP, which is simple message transfer protocol. The port number is 25, and we have said different port numbers in previous lecture, right? And I guess we should start this session. Should I start? The
Yeah, start with it.
okay. So in this session, so this is second session of networking, and in this session we're going to discuss about the IP addresses, subnetting, and networking models. Okay, so my name is Jay Makwana, and I'm going to uh, teach you about this subject. So before starting with the session, I want to ask you all that what is the importance of IP address and why it is necessary to learn IP address. Yeah, and what is the importance of IP address? Why we need to learn subnetting and networking model and all? So we will first discuss the importance of IP address, and then we will go to the introduction to IP address. Okay. So IP address in simple term is a unique numerical identifier assigned to each device is connected to a network. Okay. So IP address is a unique identifier. The name only suggests that in the network, every device will be identified with the unique IP address, right? So for example, if you want to communicate with other devices in the internet, for example, you want to communicate with your friend, so you will need an IP address. So network will be identify you. If you don't have an IP address, then you can't communicate, right? So that is the main use of IP address. There are also many uses we will see as we go through the seminar. Okay, and subnetting. The subnetting is a process of dividing the large network into smaller subnets. Now, why the subnetting is important? Now we have IP address to identify each devices, and the each device can identify other device with the help of IP address. But what we do in subnetting, we divide the networks. So for example, in a company, if we have a different department for example, one is for financial, one handles finance department, one handles development department. So we will divide both the department into different networks, So the developer can't see the financials, Excel sheets and all, and the finance people can't see the development process, right? So this is the main reason of subnetting, and there are many more reasons, same as IP address, but like we will see in this seminar. And the last thing we will see is OSI layer and TCP/IP model. So we will not go deep into this part, but I will just give you the overview. What is the OSI layer? What is the TCP/IP model? And what is the use of that? So networking model is just an standardized frameworks used to describe the communication process between device in the network. Okay, so how devices are communicating with each other, how they are recognizing each other by the IP address, how packets are traversing, how they are authenticating the packets, what is the security measures they are looking for, and this all will come in this networking model. Okay. Okay. Now let's see where we get the IP address. So, okay. So IP address. So INA is an organization which is Internet Assigned Number Authority. INA is an authority organization which provides the IP address to everyone. So I will go to the PPT and I will explain you about the INA. Okay, so it is the sub department of ICANN organization. So what is INA? INA is Internet Assigned Number Authority. So it is responsible for global Internet Unique Identifier System. What is unique identifier? That is IP address. So they are responsible for global unique IP address. So they provide the unique identifiers to every devices who wants to communicate in the network. Okay. And why does INA exist? So there is no central control of internet, right? And like the INA is not based from an central, like the organization, suppose consider this INA is in India. So we can provide the IP address to the citizen of America by sitting in the India, right? So the INA is further divided into sub domains, which are called the registries. So we will regional registries. So we will see that. Okay, so these are the services provided by INA. So they provide the domain name. Domain names means if I want to host my website, then there will be some domain name assigned to it. For example, my name is Jai, so I will make a website of jai.com. So this is the domain which will be provided by INA 2. Then number resources means an IP address. So I have a domain jai.com which I have buy from any hosting services. I buy from any domain services and I want to host that. To host my domain, I will need an IP address, right? So I will bind my IP address to my domain and I will host that. So this IP address is also provided by the INA and which comes under the INA services. The second is protocol assignment. Now we have the services. So in like globally, everyone can use the services, but we need the protocol. There should be some rules and regulation. So every user can be securely like enjoy this service, right? So there are different protocols like HTTP, HTTPS, and different ports number that which services will run on which port number. These all are provided by these INA services. So this seems like very big organization, right? Yes. So what is in number resources? They actually provide two services. One is internet protocol, which is an IP address, and second is autonomous system. Autonomous system means the unique identifier given to an specific the unique identifier given to an devices of an private centers, private organization. For example, I have company and I want to use that certain IP addresses or something. So this is an advanced topic. We will not go into that in this seminar. So we will look for this IP protocol. So in that internet protocol, so in that also we have two types. The one is version 4 and version 6. So this is the most used and currently all are using this version 4. Like 99% of internet devices uses version 4 to communicate with each other. Okay, and it is 32-bit address, and version 6 is 128-bit address. So it is not like no one use the version 6. Many companies, like big companies, use, but at very lower level, like where the cases are very rare. So I guess Geo Reliance uses this version 6 in their company, and this chart shows that the IP address 4 is now exhausting, that there are no more IPv4 addresses to provide to new devices connected to the network. So they have made the IPv4 v6, that is version 6. So more and more device can join in the network. So nowadays we have like various kinds of smart devices which need an IP address. For example, my IoT device, for example, an Alexa or smartwatches, the smart home appliances all need IP address to communicate with each other, internet, and be smart, right? So we need an addresses which can be like provided to all. So we have discovered the IPv6, which is 128 bits. So we will see that how much V4, V6 and V4 version can provide, addresses can be provided. So INA have this 5 divisions. Each are divided the continent wise. So yeah, so they are called the regional internet registries. So there are 5 regional internet registries. These are the very important to remember if you are going in the like for the examination perspective for a networking or cybersecurity or any network engineer examination. If you are giving, then this will be definitely one question that they will ask you for the registry internet regional registry name, and they will ask which region it is talking about, and they will give the region name, and you have to select one of the regional internet registry. So there are 5. One is African Network Information Center, that is afrinic. The another is American Registry for Internet Numbers. The third is Asia Pacific Network Information Center. The same way we have LACNIC and RIP NCC. So they have different continents. So we will different location they are handling. So INA, like I said before, that INA in sitting India cannot provide the IP address to the system which is in the America or the Russia, right? So there are the different centers, those look after this, and we will not look much into this because the main session is about subnetting and understanding the IP address. This is just an extra knowledge. So now how they are providing IP address. So you uses the you uses the internet which is provided by your internet service provider, right? Or if you are using the internet of Airtel or Jio, so they have their service providers. So like they are only the service providers, so you can use internet from them or you can use the internet from your ISP. That is the internet you are getting from your router, right? So if my ISP is sitting in India, like I'm in India, so my ISP will buy the IP address from this Asia Pacific, and the Asia Pacific will give them IP. So to buy the direct IP from this, you need like you should like if you want more than 250 IP address, then you can directly go to them and ask for the IP address. Otherwise, you have to buy from your ISP. Okay, and an IP address is necessary to communicate in internet. Now let's see what's the IP address. So for this session, we will stick to an IPv4 address because we will learn the subnetting for IPv4 address because no, 99% of organizations, private network systems, all are using the IPv4. So we need to learn IPv4 first. Then we can go to V6, right? So we will learn the IPv4 address and subnetting in IPv4. So what is IPv4? So this is an internet protocol, is a set of rules governing the format of data sent over the internet to or a network. An IP address is a 32-bit sequence, contains ones and zero. Okay. Mm, how many participants? Okay. So okay, so this is an interactive session. Okay, so anyone can ask doubt in between because well, with the flow, the difficulties of this, the difficulties to understand this session will increase because we can directly go and jump to the subnetting part. So it will be difficult to understand. So if you have any doubt, anyone can ask in between. Okay. So who all are present can raise your hand so I can understand that you are listening. Okay, cool.
If you guys have a doubt, then you can also post it in the chat box. We Jay will be answering it after the session also. So if you
Yeah,
don't
yeah.
want
But
to speak,
you can directly turn off your mic. You have the option to turn off the mic, right? Only two people are listening. Three, okay. Five, okay, cool. Six. Okay. So if you have any doubt, you can ask in between, or else you can put in the chat box. I will recommend to ask me in between only because your doubt will be clear, so you will more understand the further topics. Okay. Yeah, you can all raise down your hand. Okay, so IPv4 address is an 32-bit sequence containing ones and zero. So I will show you what does it mean. Okay, so my Excel sheet is visible. Can someone reply?
yeah, it's visible.
Yeah, okay. So I said IPv4 is an 32-bit address. Okay, so each and 32-bit like the 32 bits is divided into one octet. So there are four octets in 32 bits. So for example, this X is an first octet, this is second octet, this is third octet, and this is fourth octet, and this is one IP address. So instead of X, there can be like 192.168.0.1. So this is one IP address, right? So this is the 32-bit IP address. And I guess you might be knowing that the bits like computer does not understand the language of integers or characters. They talks in bits, right? That is ones and zeros. So there are like 32 bits, and all bits have the meaning. Like if some bit is on, some bit is off, then IP address changes, and that's how IP address works. So I will break down the sequence. So in 8 bits, the sequence is breakdown into this, like this, that 2 raised to 1, 2 raised to 0, 2 raised to 1, 2 raised to 2 till the 2 raised to 7, that is 8 bit. And we have to add this all, that is 255. So one octet will have the, like one octet can be written as 1, like 1 to 255, right? Or 0 to 255, or 1 to 256. So this is how IP address is written. Like if I say that this is the IP address 192.0.1. So this 192 means, this 192 means this first octet, 168 means this second octet, 0 means third octet, and 1 means fourth octet, and 192 means how bits will be on and turn. So for 92, we have to just add this number. Okay, so for 192, which number we will make on, so it will be 192. So we will make on this 128. So 128 plus 64 is 192, right? I guess, yes. So we'll turn on these two bits, and all other bit will be 0, 0, 0, and all other bit will be 0. Okay, so this is one octet which represent, this is in the bits format, okay, and this number represent the 192. So in this way, the IP address is written in. So in this way, the IP address is understand by the devices, right? So can someone tell me the bit for 168? How it can be written? You just have to add this number and make 168. I have like I have done for 192. I have added 128 and 64, which makes 192, and all other bits will be zero. Can someone tell me this bit? What will be the bit for 168?
128 plus 32 plus 8.
Yes, cool. Okay, so who was this?
Vansh.
Okay, okay. So you are understanding this all. Okay, so I will just I will just do fast. So this simple thing I will just skip if you are understanding this. Okay. So can someone tell me the bit form of this whole IP address? 192.168.12.5. You can type in the chat box. Let's see how many reply comes. For this IP, you have to calculate. For 192 and 168, you know, you just have to calculate for 12 and 5. This is very easy task. Reply fast. Anyone is doing, or I should give the answer? Once you are doing.
Yeah, just 2 minutes.
Yeah, okay. Okay, so this is for 192. This is for 168. Come on, guys, come on, guys, tell me about 12 and 5, how it will be written in bit format. This is very easy. For 12, you have to add this 8 and 4. So tell me what will be the bit. Okay, Deep has written for 12. Yes, that is right. And for 5, it will be 4 plus 1, right? It will be 0 0 0 0 0 0 1 0 1. Yeah, so this is how in bit this IP address will be written. Yes. Okay. So this is how the IPv4 address is written in bits format, and you can calculate this. If you know how this is divided into octets, and so this they divided into octets, so we can learn about the subnetting part. So in the PPT, okay. So IPv4 is divided into 5 classes. Just wait for a second. Uh, uh, I guess chat is not all, like attendees can type in the chat. Can someone reply?
No.
No. Okay. So you guys can speak if you can't type. Okay. I
Yeah,
thought
sure.
I thought you can type. No problem. Okay. So IPv4 is divided into 5 classes: class A, class B, class C, class D, class E. And like we seen that 1 octet can be written as like any number between 0 to 255, right? So we can write 1 octet as 1 to 255. So on the basis of that, we have divided the IP addresses, the pool of IPv4 addresses, into classes, and all classes have the different meaning. So we will see subnetting of each, how to find the number of host networks, and how to divide each network. So we'll see that. Uh, Before that, let's understand what this class means. So in A class, you have the IP address range from 1.0.0.0 0.0.1 to 126.255.255.254. Okay, just a second. Yeah, so IP, okay, so class A, this is the range for class A. For class B, the range is from 128 to 191. So this all range you should be remember. So this is like you should know about this range. Terror. You should be like know this range. And in C class, the range starts from 192 to 223, and D class 224 to 239, and in E class 240 to 254. So class A, B, and C are used for networking, routing. So we can use these classes. Mostly we use like 90% all use this C classes, and D classes is for multitasking address. Now, what is the multitasking address? Multitasking means your router is connected to your neighbor's router, and all are interconnected, right? All routers are interconnected, all network are interconnected. So they are called the multitasking. So if you have checked the net set of your devices, there is one command in CMD, that is command line of the Windows. Or if you are the Linux user, if you are tried in the terminal checking the hops of your network, that if you ping for in google.com, then your packets will traverse from one router to another router till the Google server. So you can see hops, and that network will be the IP address of that network will range from this IP address. So that is the multicast. So so this range is used for multicasting. The E class is is for reserved for the experimental use, research used, future use. So till now, and not a single device support this IP address because it is reserved for the future use or research use. I don't know exactly what this IP address used for. No device support this IP address. If you set manually this IP address to your network, they can't be supported. So I forgot to tell you about the static IP address and dynamic IP address. So we have learned this all. We have seen this all. IP address used to identify machine network. Okay, IP address consists of 4 sections, and the one section is 1 octet, right? Okay, and the types of IP addresses, one is static and one is dynamic. Static means you can change your IP address manually and give the static IP address which you want. So that will be not change if you connect and disconnect to network. Your IP address will remain same in that network. Dynamic IP address, which is provided by the DHCP server, that is DHCP server, which is like the IP address provided you to the by the router. So that is dynamic IP address, and that IP address have the like time limit for like for specific after a specific hour, your IP address in the network will change. So that is the dynamic IP address. By default, all router assigned dynamic IP address. Okay, so we have seen the classes. Till now, anyone have any doubt? Because from now we will
Uh,
start subnetting.
what is more convenient, static IP address or dynamic IP address?
Okay, so it's again depends. Like if you are an administrator, or if like you want your employee, like there are 5 employees, right? And you have to track all employees. So like you should know the IP address of all employees by the name. For example, the Akash have this IP address, Raju has this IP address. So you can like scan them properly. In the home network, you can like go with the dynamic IP address, because it doesn't matter if our IP address changes. If you want to like for security purpose, you can give IP address to your home network for the different person. For example, you give different IP manual, like static IP to your brother, static IP to you, so you can recognize them. Okay. And you can also set the router as by default static IP address, so no one can connect it with your router. Like your route, you have to shut off your dynamic IP address assigning. So that is again for security purpose also, security purpose.
Okay.
Yeah.
Bro, can you explain the classes again? The class A, B, C.
Okay. So in classes now, so you understand how why we write like we can write the IP address like in one octet we can write from 1 to 255. You understand this? Understood
Yes.
this? Yeah, okay. So we have like so many IP addresses. So we have divided them into classes for different purposes. So for like, for example, E is reserved for future use, right? D class is used for multicasting. You understand the multitasking, or I should explain it again?
No, bro, I know.
Okay, you understood.
Yeah.
Okay. So for the different uses, we have like divided this IPv4 into different classes. So that is main point of this. And different classes can provide different number of networks. So this is the number of networks it can provide. For class A IP address, this IP address, like there can be 127 networks, and each network can have 16 million, no like there is some number, so each network will have that many hosts. So we will see that in subnetting part, how to divide how to know the number of networks of each class, or how to calculate the number of hosts for IP address. Okay.
Yeah.
Yeah, so we have divided this IP address into classes so we can use them effectively, and each classes define the different use case. Okay, so now we will start with the subnetting. So anyone have any doubt till now? We will, if you don't have any doubt, then we can start with the subnetting. But okay, so you have understood this, how octets are divided into bits and how you can calculate the bits of the given IP address. So now if anyone gave you any IP address, you can calculate the bits of that, right? So this is the simple method to calculate the bits of IP address. Now this is how the classes are made by the INA. So these are the bits wise calculation we have done before, that is the same, and I have written the value of that 2 raised to 7 is 128, and same goes to this. So if I uh, turn off all the bits of one octet, that is 0000. So my range of IP address, that is my range of octet will be from 0 to 127. Now, can anyone say why this is 0 to 127 only? Why it is not 0 to 129 or something greater than 127? This is class A, okay? Okay, I will tell you.
Maybe the limit is issued,
Which limit?
limit of 128.
Yes. So no bits is turned on, right? So this octet can traverse from, like, if we set this 1 bit to 1, if we set this 2 bit to 1, if we set this bit to 1, then if you set all the bits but not the 128, then my octet range will be can go from 0 to 127 only, right? So this is the class A. We are talking about only first octet. This one X. We are not talking about this other 3X. Okay. So this is just for explaining the classes, how classes are divided. If I set the 128 bit, so my IP address can range from 128 to 192. If I set, I'm just talking about this octet. Okay, this octet. If I set 128 and 64, then my IP address can go from 192 to 223. So this is how the classes are divided. If you not understand this part, then it's okay. This is just an extra part for understanding the division of classes. If you get to know about this, if you remember the range of classes, then that's enough, more than enough. You can learn the subnetting. Okay. Okay. So now we will start with the subnetting. Mhm. So if you have seen in the if you have used the nmap, or if you have seen, then IP address is written in this format. That is, if for example this is an IP address 192.168.0.1/24. So this 24 defines the subnet mask of an IP address. Means this IP address, I guess. Okay, before this, I will explain you about each classes, the default host and network. Then we will go to the subnetting part. Okay. So this is the template where we going to write, and this is the reference template which I have already written. So we can take the reference from this. Okay, so A class is used for network, D for use for multicasting, and E is for experimental use. Now in A class, okay, for A class, now I have like we have seen, the one IP address can be divided into 4 parts, that is in 4 octets, right? And for class A, we have the first octet as a network. So each IP address is divided into network bit, uh, IP address is divided into 2 part. One is network bit and another is host bit. Okay. So network bit defines the number of network, and host bit defines how many on which host for which for specific which host is IP belongs to. And by knowing the IP address net bit and the subnet mask of the IP address, we can calculate the number of hosts this IP address can be assigned to. Okay, so for class A, we have first octet fixed for the network bits and other 3 octets are used for host bits. So there are 24 bits used for host and 8 bits used for network, right? So how to calculate subnet mask for that, we will see this. So this will use this. So A class use the subnet of 8. Okay, let me see. I have not mentioned this. Okay, so this is class A, class B, class C and class D. Okay, so class A can use the subnet of 1, 2, 3, subnet mask of 1, 2, 3, 4, 5, 6, 7 till the 8. So we write for class A, we write always subnet mask as /8. Okay, so mm, okay. So subnet mask can be written as 255.0.0.0. Why 255.0.0? So these bits are already fixed, right? So we don't have to touch this bit. We can only change this bits. So the max, so we will write this at as 255.0.0. We can't add another number to 255. We have seen that we can only assign number from 0 to 255, right? Okay. So we will now calculate the valid number of network. Okay, so valid number of network will be 126. And how I have calculated this? So in the first octet, we have range from 1 to 126, right? So for in the network bit for class A, we have considered the first octet is for network bit, right? So we will only talk about the first octet if we are talking about the network. So we will see how many network we can create. So we can create network from 1 to 126, and we are not talking about the other 3 octets because they are used for host. We want to calculate the number of networks, so you can calculate number of networks. This is going from 1 to 126. So this is the number of network. For calculating the number of host, so we have to calculate we should know the number of host bits. So for class A, there are 24 host bits. So the simple formula is 2 raised to 24 minus 2 will be the number of host this IP address, this subnet can provide, that is /8 subnet. This subnet mask, that is this subnet mask can also written as /8. Okay, so this subnet mask can provide this many hosts. That means this many IP, this many I give provide the IP address to this many hosts. Why I have done the -2? Because the first IP of the subnet will be given to network IP. So that will be given to my router in if a router is providing me the IP address, and the last IP address will be the broadcast IP address. So it will also reserve. So 2 IP addresses from the total pool is reserved for the network IP and broadcast IP. So we are doing -2 for that, and these are the valid host IP. So if we consider the IP range of 1.1.0.0.0, if we consider this IP address, so we have to so what will be the first valid IP? So this will by default the first will be the network IP. The second one will be the first valid IP. So from this, the host will get the IP address till what? It will get the IP address till this. 1.255.255.254. Okay. Now, can someone say why it is till 255? Okay, so we can write the single octet can only can be represented till the number 255 only. Okay, so this is the last valid IP, and the last IP from the pool will be given to the broadcast IP. Okay, so this is for the class A. So this is how we can calculate the host, that is 2 raised to two raised to number of host bit, which is the 24 in the case of A. So we have also the range of private IP address, which is used for LAN environment, and the IP address ranges from 10.0.0.0 to 10.255.255.255. So this range is reserved for private class. Okay, and we have
So
127.
where is the broadcast IP used? Like network IP is used for routers, so where is the
Yes.
broadcast IP?
So this IP address is used for recognizing the network, that is the router who is providing you IP address, right? And broadcast IP address is used to provide IP address. Like you know about the ARP protocol, address resolution protocol. Like to communicate in network, the router should know your MAC address, right? So first, when you connect to router, you ask for IP address to DSCP. Right, so DSCP, that is the router which will be having this IP address, and you are and if you are requesting for IP address, if you are requesting for any service, that will be provided from this IP address. So if you are asking for an like, the IP address will be broadcasted from this IP address, the communication will be broadcasted from this IP address, and the other routers and network can recognize other networking device can recognize your router with this IP address.
Yes.
Okay, so that was the for class A. Now for class B, we have ranged from 128 to 191, right? So we can also write here, but we are lagging of time, so we will just hurry. Okay, so for class B, we have 16 bits for network, which is fixed, and for there are 16 bits for host, right? And this is the subnet mask. And in this slash format, we can write it as 16/16. So you can call the subnet mask, and if someone asks you the subnet mask, then you can say this. If someone asks for subnet mask IP, then you can write this. And if someone simply asks you about the subnet mask, then you can also write in this format. Okay. So in class B, the number of valid networks is calculated as 64 into 256. Can someone decode this? How it is written in this format? 64 into 256.
64 for 2 octets and 256 is the value of each.
64 for 2 octets.
Yeah,
No,
8 and 8. 8, 8.
no, 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 no. It's not calculated like that. Uh, okay, so I will tell you. Uh, so in the A, for the case of A, you understand how we calculated the number of network for A?
Yes.
Yes, so we are traveling from this one to 126. So we have only considered the first octet, right? From 1 to 126, because in class A, the network bit is considered in the first octet only. So we have considered the first octet only. But in the class B, we have two octets for network bits. So if we consider the first, that is from where to where we will get IP address, that is the range of first octet. So range of first octet is 128 to 191, right? So how much network will be provided between this range? So it will be 191 minus 128. That is 63. So for first, if we look for this first octet, so we will get 63 network. But in class B, we also have the second octet. And what will be the range of this second octet, till what number it can go? It can go from 0 to 255, right?
Yes.
Yes. So we have to consider 256, 256. Why? We have also considered the 0, that is 0 to 255. So that is total 256. So the first So the first octet tell us there are we should we can create 63 network by just subtracting this two number. And second octet is also about networking. So we also have to consider this, and we can multiply this, and we will get the total number of network bits. Okay. Now for the calculation of host, we have the same formula, that is 2 raised to the number of bits. Okay, so in class B, we have 16 bits for host. So we simply do 2 raised to 16 minus 2. So that is 65,534 host we can this IP address can generate. Okay. So if we consider this IP address, so this will be our first, what will be this called as? The first IP will be reserved for network IP. The second will be first valid IP. This will be the last valid IP. And the last IP will be for,
Broadcast IP.
yes, very good. So this is broadcast IP. So in same way, we have to do for class C and class D. So in the case of class B, the range of IP private IP address is 127.16.16 to 120, sorry, 172.16 to 172.31. Okay. So total 16 networks are reserved for the private class. And there is again one range which is defined as a PIPA, that is 169.254.0.0 to 169.254.255.255. And the full form of APIPA is Automatic Private Internet Protocol Address. So this is used for like if your router does not provide the DNS to your DNS name uh, to your device, then your device will use this range of IP address. Okay, you can research on this. There are like this is one topic of network. Okay, this is one single topic. Okay, so we have seen for class A, class B. Now we will see for class C. So now you guys tell me, there are 24 network bits, okay, and 8 is host bit. Just a second. Okay, so 8 are host bit. Can someone tell me how we can write the subnet mask of this C class IP address. For A, we have written as 255.0.0.0. For B class, we have written as 255.255.255.0.0. How we can write the subnet mask for C class IP address? Yes,
255.255.255.0.
yes. And in slash format, how we can write?
Slash 32
No, it will be 24.
24.
Yes. So this is depend on the number of network bits. So if you have seen in the class A, we have 8 network bits. So we can write that as slash 8. For B class, there is 16 bits. So we have written as slash 16. Now in C class, we have 24 bits reserved for C class. So we can write as slash 24. Okay. So this is how we can write. Now we have 8 host, 8 bit for host. Okay. Not 8 host. Okay, so this is the most common subnet we all use, and the range of that is 192 to 223. This is the first, I'm talking about the first octet, okay? The first part of IP address. Now, can someone try to calculate the number of valid networks? That is the number of network this subnet can provide. For A, we have calculated it as 126. For B, we have calculated as for first octet is was 63, and for C it was going till 225. So we were doing multiplication of that. So 63 into 255. Now for C class, can someone tell me the number of networks? Vansh, are you trying?
Yes.
Yeah, okay. Have you calculated?
Uh, 31 into
Yes, 31 into 31 into 255 into 255. The range of other two octet will be remain same, right? The range of first octet is changing because we have divided this first octet into the different ranges. So we can only go from 192 to 223. So we can only have 31 network. But for the like second octet, We are going from 0, right? So we can go till 255. So this will remain same. So this is the number of network this IP address can provide. Now, this is a simple question. Uh, how many hosts this network can provide, this IP address? The formula is 2 raised to n minus 2. Minus 2 is because we are not considering the network IP and the broadcast IP. This is for the valid host, not for the network and broadcast IP. So this is the formula. Yeah.
Somewhat. Uh,
What is the n over here? What will be the value of n?
Number of networks 31, I guess.
No, no, no. N will be the number of host bit because we are calculating host. For calculating network, we will consider the network bits. In this case, we have 3 octets. That means 24 network bits. And for calculating host, we will only consider the host, not the network. In this case, we have only 1 octet for the host. That means 8 bit. 2 raised to 8 is 256, right? Minus 2, 254. So number of valid host will be 254, right? So if I consider the first valid range, this is the range of IP address. Let's consider the IP address ranges from 192.0.0.0/24. Okay. So now tell me the network IP, first valid IP, first valid IP. Yes, if you answer, then you can say last valid IP and then broadcast IP. Yes. Tell me what will be the network IP in this case?
1.0
Okay.
sorry,
Okay. How one dot?
starting it goes to the router. So in
No, it's not like that. So this is the range of IP address. This is what like IP address with subnet mask. Okay. So in C class, the IP address will always start with 192 and it will end with 223. Okay. So don't miss this. You have to only consider this range. So the first network IP will be 192.0.0.0, same as this. Now tell me what will be the first valid IP? 192 dot. What will be the next IP of this? It will be 0.0.1. Okay, and it will go to 192.0.0.2, then .3.4 till 255. After 255, it will change this bit and it will again start with 1, 2, 3, 4. Okay. So what will be the last valid IP for this? So in class C, uh, we have only 1 octet for the host bit, right? So our host can be like listed in this octet only. This number will be not change, right? You understand why? Because this is fixed for the host bit, network bit. You only have to change this. So tell me what will be the last valid IP. Okay, tell me the broadcast IP at least.
192 dot
Yes. 192 dot.
to
Oops. In 32.2. No, no. I
the
said
zero
this 3 octet will be fixed for network. Okay. We are only talking about host if like this is the IP address and what will be the range of IP address of this in class C. So in class C, we only have last bit which we can change, that is for host. Okay, so we can only change this bit. We can't change these 3 bits. So the last broadcast IP will be 192.0.0.
255.
Yes, 255. We can only travel in this range. This is one network. Okay, this is one network. In this way, how much network we can make? This is one network. We can make this many network, and each network can have this many hosts. This is what we are calculating. Okay. So for A, there was only one network bit and uh, 8 network bits and three octets for the host. So we can change 3 hosts. You can see here it's starting from 0.0.0 and at last it is ending with 255.255.255. So we can change these 3 octets because these 3 octets belong to host bits. In B class, we have these 2 octets we can change for the host bits. Okay, so we can only change these 2 bits. So in this range, you can see the the IP starting from 0.0 and it's ending to 255.255. We are not changing this 2 bit because it is network bit. Okay, so in class C, we are doing same. We can only change the last bit. So our network is starting with .1 to the .255. You understand, or I should explain you again?
I understood.
Okay, you have any doubt till now?
For last valid IP, the it would be 254, no, in the last line.
Yes, yes. Very good. Okay. And this slash 24 is also known as CIDR, which is classless interdomain routing. Okay. So don't forget this. I will also provide this writing material for the reference, so you can refer that. Okay. So now let's go back to this Excel sheet. So Uh, you guys want break of 10 minutes because I was thinking to complete this session. It will last for 15 more minutes. Uh, you want break for 10 minutes?
You can finish it off right now.
Okay, okay, that will be great. Okay, so this is 4 octet. You can see here, this is 1 and this is the bits. This is the value of that bits. Is it visible, right? Or I should zoom in?
Yeah, it's visible.
Okay, okay, cool. So in this, we have this is the class. This is slash 24 which means which class it is talking about? C class, right? Slash 24.
C.
Yes. So if we change the number of bit over here, let's turn on this bit as 1. So it will go to slash 24. If we set this, if we turn on this, if we turn on this bit, then it will go to slash 26. And this is like if we have done all the bits, then the total of this number will be 255. If we turn on all the bits, the total number will be 255. If we are turning on this 2 bit, then the value of octet will be 192, right? And this is how the subnet mask is changing, and this is the number of host, that is 2 raised to 6 Why it is 2 raised to 6? Because there is only 6 bits which is remaining for host. These all turn on bits are reserved for network bits, right? So if I change this as 0, oops. So if I make a 8-bit available for the host, then it will go to /24, and the number of hosts we can calculate as 2 raised to 8. So this is the sheet I have Excel sheet I have created to show you how the bits and subnet is changing on changing the number bits of octets. And remember one more thing, you can never change the bits from here because it will give you like weird subnet. So okay, so like the number of hosts will be calculated in the wrong manner. You always go with changing the higher bits, okay, for the network bits. So if you want to reserve network, then you always go in this direction. We not randomly turn on these bits, okay. If you are randomly turning on these bits, which means this is the host octet, okay. This define the host network. Now let's see how to calculate. Now we have calculated the number of hosts for class A, class B, class C with the default subnet mask, that is /8 /16 /24. We are not talking about D and E because that is not used in subnetting because it is used for multitasking and reserve. We only subnet the network, and network bits is only in class A, class B, and class C, right? So we are only talking about class A, class B, and class C. So we have calculated the number of valid network and number of hosts for this default subnets. But what about if I give to calculate, if I give you to calculate the number of hosts for /6? If I give the IP address you like 1.0.0.0/6, then how you will calculate the number of hosts? So for that, like you can also go with this formula only, that is 2 raised to number of network bits. Number of host bits. I'll show you here. If I gave you the range of, if I gave you the range of this, okay, so how you will calculate the number of hosts from this? So to calculate this number of hosts, the formula is uh, 2 raised to n minus 2, right? Now, what is the n over here? N is the host bit. Now, can someone tell me what will be the number of bits, host bit in this IP address? First of all, we have to see which class it belongs to. This is a class 8 and below. The /8 and below this, below 8, it will be considered as class A. So it is class A, right? Now, how many host bit class A has? It has 24 bits, right? But it's not talking about /8. This is for /8. We have to look for /6. How many bits will be available for /6? So again, I will do this 1.2, 5, 6, 7, 8. Just a second. See.
26.
26 bits. Okay, so this is the default class A, and this is for /8. What we are talking about /6. Just a second. I'm doing my calculator first, then I will show you. Yeah, so the basic trick to remember is you can have total, you can go till /32, right? And you have /66. So how to calculate the number of host bit is simple. By total bits, it can go minus total subnet, total subnet, or you can say the total bits, it can go minus the bits or subnet given. So this, like the bits or subnet, which is subnet is /6, right? Let's consider this as X minus the subnet is already given, which is 6. And we have to calculate from the total, we have to minus it, subtract it from the total subnet, which is /32. Okay, so what is 32 minus 6 is 26. So there are 26 bits available for host bit, 26 bits. So you don't need to write this all form. You just have to remember this small trick, that how many number is given after this slash. You just have to subtract it from the 32. It will give you the number of host bit, which is in this case is 26. Now you can calculate the host, right? Which is 2 raised to 26. How much it will be? Yes, it will be 67,108,864, and you have to do -2. Okay, so this many host the one network can have, and how many network this IP address can form. The network this IP address range can form is same as the class A. The network doesn't change, okay, in this case. The network will be remain same as the class A. There it is. Yeah, the number of valid network remains same, but the number of valid host changes if the this /8, which is the subnet, must change. Now this table, if you now I will show you the simple trick to calculate the number of host and number of number of host. Okay, so by making this table, you can like simply calculate the number of host. So what this table is about, this is the CDR value, that is /1, 2, 3, 4, and it's going till 8 bits. Then again it's going down, coming down. Then again it's going till 8 bits. Then again 24 and 32. So these are the 4 octets: 1, 2, 3, 4. So these are the 4 octets of an IP address. Okay, and depending upon the CDR, the number of hosts is changing, right? So we have common subnet mask, which is /24. So this is the common subnet. All should remember the number of hosts of the common subnet, which is if /24 comes, then then you should click that. Then you should know there should be 256 hosts in that range of IP address. Okay. Now how to make this table? I will just write this table as 1, 2, 3, 4 till 8 till 32. You just have to make these three octets. You don't have to write number of host. Okay. Okay. Now in class A, if subnet is starting with x dot 0 dot 0 dot 0, which means the first x tells about the network bit and other three is for host. In the class B, the first and second is for network bit. Just a second. Okay, so we are already, I have already taken much time. So if you want, then we can continue this session in the next session because it will take around 15 to 20 minutes. What you guys suggest, or I should continue? Hello.
Jay, can you cover it in short a bit and complete it today only?
Mm, okay.
Just teach the main points.
Okay. Okay. Deep. This will like take 20 minutes at least. I was thinking to do in next session. We will just arrange an half
Yeah,
an hour session.
that should be. Yeah, I mean, I was going to say the same that we could keep it in the next session so people would have some other doubts as well.
Yeah, yeah. So till now, if anyone have doubt, then they can ask. And in another session, we will like finish this part in half an hour. Okay.
Can you just share
So
these notes and Excel sheets as
yeah,
well?
yeah, yeah. I'm going to share this all text file and this Excel sheet also. Okay. So I will share you this and also, yeah, so I will also share you this, which we are going to cover in next session. So in next session, please attend. So we will complete this part. Okay. And we will also discuss interesting, like I will give you the assignment of different IP address and you can find the number of hosts and networks of this. Okay. And
Yeah,
from the last session, I will request you all to like make this session interactive because it is very complex topic. This is all about numbers. Even I got confused in between. So if you are guys are interactive, then like I will be on the flow and we can also like discuss about that. Yeah, this is and this subnet is going like this and this all. Yes. So I will just okay. Anyone have any doubt?
no doubt.
Okay, okay, cool. So yeah, so I will like to conclude here and we will continue in the next session. We will arrange in half an hour session.
Uh, okay. Firstly, thank you guys for attending the session, and I highly appreciate all of your participation in the past two sessions. And we also thank Jay Makwana for sharing all the insightful knowledge that he had, and practically showing us what all things have been happening. So I have a good news for you all. Soon we might have a offline session in our labs. So I request, if you could tell your friends to attend the sessions because now on we will try to keep them offline and in person. So you can, get hands-on on what the person is trying to teach. So I highly appreciate if you could all spread out the messages. And yeah, thank you for attending the session. You will receive a feedback form in the HHSC group. So please fill that, and that's how you'll get your certificate for the session. Thank you.
Thank you so much, miss.
Thank you.
Thank you.